Congratulations to everybody watching this who has been with us since Monday. I mean, it's been an incredible program, and this is a fantastic topic on which to bring this stage on CogX to a close. And I'm delighted to have my dear friend Juan Carlos Castilla-Rubio with us today. JC, as I'm going to refer to him today, is the chairman of Space-Time Ventures, which is focused on science-based ventures, looking at natural resources and making sense of nature's intelligence. We met through the World Economic Forum in Dubai a few months ago. And he's the founder of the Earth Bank of Codes, which is the project that we are going to talk about today, the project to uncover the Book of Life. JC, lovely to have you here, and good morning.
Good morning. Thank you, Azeem, for that kind introduction. And I'm very grateful to share a stage with you. Because of Exponential View and everything that you've been up to over the last few years. I'm an admirer of your work and your group, so it's a privilege to be with you.
Well, we're going to have an exciting 42 minutes together now with, I think, the order of play is you're going to talk to us about the Book of Life, and then we'll have a conversation between the two of us for the next 25, 30 minutes after that. And just to the audience, please do send in questions via the Slido or the CogX app. There's a lot in JC's vision, and there have been many opportunities to ask questions, and I'm happy to take them. I have more than enough questions, of course, myself. But without any more delay, JC, over to you. Let's hear about the Book of Life.
Yes. So let me start a quick summary of the journey that we're in, that it actually started about 35 years ago, back in the Peruvian Amazon. Sharing with you a story that, in contrast to our friends in chemistry that developed the periodic table, almost completed the periodic table back in the 1930s, that is, of course, behind a number of chemical innovations that transformed multiple industries. Our friends, the biologists, have a lot of work to do because if you look at complex life on the planet, life that has a nucleus, we've only done full genome sequencing of about 0.28% of that life. In other words, we have only written about 0.28% of its chapters. But of course, that began to change about 2 years ago when in Davos, we launched the Earth Biogenome Project that has begun 2 years ago to fully genome sequence all complex life on the planet over the next 10 years for the same dollar value, incredibly, that cost us to genome sequence the human species. Of course, we all know that genome sequencing reduced in cost about 1 million times, and that's why we're able to do this now. Now, one thing is to write the Book of Life, which is very complex, and we will talk about that later on. But quite another is making sense of the Book of Life. And of course, this requires a combination of technologies that will just net out as if there were one, and let's call it computational biology. And this of course entails to a large extent making sense of a very large data set, which can run into many times fold the type of data sets that we encounter in social media or even in astronomy. We're talking about 70,000 petabytes per year, which is a genomical scale, far larger than astronomical scale. And making sense of the Book of Life is critical for 3 fundamental reasons. Number one, because it will provide a foundation for biology. Number two, because we will then learn how to preserve life on the planet that, as we all know, is highly challenged. And number three, because we believe that nature over the evolution on the planet has actually worked out the solutions for multiple problems that we face. And just as a data point with respect to that, over 3.5 billion years of life's evolution on the planet, just as a little example, we humans are only capable of synthesizing about 3 to 3.5% of the type of chemicals and compounds that nature is able to produce. And I won't go into the technical details of that now, but suffice to know, perhaps, that it is almost, I think, a given that a revolution in biology that basically is related to automated biological discovery, computational biology, and synthetic biology in sequence will transform multiple industries over the next few years, will unlock a very large-scale bioeconomy running probably in the trillions of US dollars. And it is my dream that this large new bioeconomy is actually an inclusive one, that is respectful of people and is respectful of nature. And importantly, that it is also developed, not only developed, but also developed in the tropics as part of adopting a new economic, social, and environmental development plan that is focused on the biological assets that are resident in the tropics. And it is for that reason that I want to talk to you about a foundational layer, which is a foundational layer that is associated to autonomous biological discovery to write and make sense of the Amazon's book of life. And we'll talk about more later about why we need a foundational layer to autonomously discover life in such a complex environment and such a rich environment as the Amazon later. But why the Amazon? Why the Amazon? The Amazon, putting it very directly, we are focused on the Amazon because the Amazon, on the one hand, has anywhere between 25 to 35% of all complex life on the planet. And this life, of course, lives in an amphibian environment, in a set of aquatic, terrestrial, and aerial systems that are interrelate with each other in a very complex manners where we lack understanding and knowledge. We also are focused in the Amazon because there is a very high risk indeed of up to 60% of the Amazon being transformed into a degraded savanna. And if this indeed happens, or potentially is already happening, this would be catastrophic, not only for the region, but for the world at large. Not only because of the climate considerations, but also naturally because of the biodiversity considerations, the loss of biodiversity in probably the richest ecosystem of the planet. But even beyond that, the Amazon basin, given this major ecological disruption that has a high probability of occurring over the next few years, the Amazon basin is probably the home of the largest pandemic level viruses reservoirs in the whole planet. And the reason why that is the case is because these virus pools in bats, in monkeys, and in rodents actually have the largest diversity in the world, and their home is the Amazon. And up to now, this region in the world has been not so disturbed to the extent that these viruses have spilled into humans and created the type of event that we're witnessing in the world today. One of the focal areas that we want to, that we're driving in our biological discovery efforts is to hunt for these pandemic level viruses so that we can sequence these viruses and develop in advance the vaccines, the diagnostics, the therapeutics that will be needed when and if these viruses come out into the open and infect humans in a very large scale. Now, coming back to biological discovery of the general type, what is interesting to note is that with current methods, which are analog, let's say, on average, with biologists, with ecologists in their field trips in the Amazon basin, discover about one new species every 3 days. We believe this is a very, very small proportion of what actually exists there, maybe 1% of total life that is present in the Amazon. In contrast to that, of course, NASA, with its astrobiological mission of searching for life on Mars, and actually the Perseverance mission is planned to be launched this July, is similar in nature to the type of effort that we are undertaking in the Amazon basin. In our case, of course, to search for life in the Amazon, because we believe that it has coded within the information and the processing of that information that happens in the Amazon, the solutions for many of our problems, as we've discussed before. Now, of course, we are focused on these autonomous sensing robots, therefore, for biological discovery. Autonomous sensing robots, which are aerial, which are aquatic, which are terrestrial, in order to write and make sense of the Amazon's Book of Life. And to do this, we have convened the global leaders in science and technology, both on the autonomous sensing robot side, not only the autonomous systems and the sensing payloads, but also the computational biology platforms that are required to make sense of the Amazon's Book of Life. Now, I mentioned to you in the beginning that even though we're focused on the foundational layer of writing the Amazon's Book of Life, what is important for us is not only writing the book, but what is important is to orchestrate a public-private commons to unleash an inclusive bioeconomy in the Amazon. And what is an inclusive bioeconomy in the Amazon? For us, an inclusive bioeconomy in the Amazon is an economy that naturally leverages these biological assets, but that is an economy and an economic development model that can be in harmony with the peoples of the Amazon, with the traditional communities, with the indigenous communities, which are the custodians of nature in the first place. And second, there can be an economy that respects forest standings and rivers flowing and life being preserved for future generations. And this, of course, is very hard to do. Very, very hard to do. And so if you look at the bottom layer of this systems level change that we are orchestrating, of course, the foundational layer has to do with autonomous biological discovery, but then multiple other layers in Amazon-based R&D need to take place. Also, a layer that has to deal with access and fair and equitable benefit sharing in compliance with the Nagoya Protocol. And if you go above the two top layers, of course, you're going into areas applying computational biology to discover, build, test, and learn in order to be able to develop the biological startups of the future to solve for X. My personal dream is that we are able, that we in the Amazon, in partnership with global leaders of science and technology, are able to orchestrate this complex public-private commons in order to go into another mode that is respectful of nature and the peoples of the Amazon. And with that, I'll stop, Azeem.
Idea, even where you and I have discussed this a number of times before. Before we get into my questions to you, I would just like to remind the audience that we are taking questions through Slido in the CogX app, so please do take a moment to look at them. So I'd like to start with a first reflection. I mean, one of my first reflections about this is when I hear you talk about this, I think of I realize that the Amazon is a little bit like a giant computer, or perhaps a giant network of computers, or perhaps it's a giant network of computers.
Yes.
In the sense, it is almost its own. We can almost think of it like an internet. I mean, what you've described, the interrelated parts, the layers in that final slide of yours, where you talk about sort of baseline technologies all the way up to the applications over the top. It does remind me that we're not just talking about what is often called the lungs of the world, but perhaps it's also a computer in of itself.
Yes, yes. Very, very interesting analogy. And I think the analogy can be taken to the extreme in that the biological processes are, of course, information processes to a large extent. And so the information processing at the species level, at the ecosystem level, at the interspecies level, is in fact the networks of networks that you're describing. And this is why, in fact, the Amazon basin, like other very rich ecosystems around the world, having evolved over billions of years, have been able to adapt to their conditions and processing more and more information and getting richer in the learning, in the computational biology that is embedded to the system, that is inherent to the system. So I think your analogy is a beautiful one and an accurate one.
So we will come back, I think, to that analogy and have it reflect on some of the questions of governance of this system that you alluded to. But why don't we wind back and just tell us where you are today with this vision. What has actually been built? What is actually operating?
Yeah, no, all of this is in prototyping mode. We haven't built this at scale. These technologies, to a large extent, do not exist. I was recently discussing this with one of our partners, and happens to be an astronaut that is part of our consortia, that was sharing with me the story that he doesn't know whether it's easier to go and find for life on Mars versus finding life in the Amazon. Because most of the Amazon is inaccessible to humans. The search that we can do for life is in the edges of the Amazon with current technology, and so we are actually designing, building, prototyping, and testing in the Amazon technologies that don't exist today, which is therefore very similar to what the Perseverance mission aims to do with searching for life in Mars. We're we have the institutions around the problem that have the deep expertise in the different sensor payloads, in the different autonomous systems, in the different computational biology components and technologies. And we are in the process of designing the blueprint and building the prototypes of executing that bit.
So we're in the design and the piloting phase.
Yes.
When you think about the bottom layer of the K initiative, which is the autonomous biological discovery layer that you so ably described, could you just describe to us how you imagine that actually working? Are we going to see little amphibious autonomous vehicles swimming out and taking small samples of root systems and then bringing them back to a lab where they then get analyzed? Is that the picture that you have in mind?
A little bit like that. Let me give you one of the actual use cases. So in the Amazon, when you visit the Amazon, you will see that there's always one little tree that stands above the whole canopy layer, and that tree typically has an orchid and has an orchideal pod. Think of a little swimming pool,
right?
Collecting water because it rains all the time or almost all the time. And this is where monkeys feed, where bats feed, where all sorts of insects feed. And this is a target for us. And so imagine an autonomous aerial system equipped with in situ genomic sequencing, looking for the remains of virus in that soup, let's say, where monkeys and bats are drinking. It is a search target for those pandemic level viruses that we were talking to before. And so with the data, of course, then the autonomous vehicle comes back to a central location in the Amazon where the computational biology routines are run.
Right. So we have, how much of that technology would you say is already at a point where it can be deployed at the right price point?
Yeah, we have set ourselves 5 years for design, build, testing, and operation. And we believe that at the end of a 5-year cycle, we will be able to, we aspire to have autonomous systems for biological discovery that can scale at a cost point that we can write the Amazon's Book of Life. So that's our plan.
Yeah, I mean, what's lovely about this plan is that you are riding a whole set of Wright's law curves, whether it is battery, lithium-ion battery storage, or autonomous vehicles, or genomic sequencing, or computation. I mean, all of these things stand strongly in your favor. So the engineering suggests that this can be done, which is great. Let's just turn to why we might want to do this. And I'm going to break this up into, I think, 3 sections. So you talked to us about a couple of things that were what this would do for us if we did it. There was a kind of profit motivation to it, which is we might discover drugs or ways of synthesizing new compounds that we need, that the Amazon has learned to synthesize. The second was the avoidance of loss, which is that we might avoid a pandemic viral release of a kind that makes coronavirus look like a metaphorical stroll in the park. And I think there's a third category, which I would say is not about profit, it's not about loss, it's actually about our own humanity or our own flourishing. It's a sort of virtue-based set of reasoning, which is that we might do this because there's value in respecting indigenous systems, and there's value in respecting nature's diversity. So I think that there were 3
Yes.
characteristics that we could go into. So let's just briefly go into each one in turn. Let's start with the profit mode driven one. It seems to me that you're suggesting that this is a pharmaceutical research engine or a materials research engine, that we could tap into that. What gives you the confidence that that is actually the case? And what do you think might be the first things to come out into a pipeline of useful inventions from there?
Yeah. So we have to go back to the 18th and 19th century to remember about rubber trees.
Mm-hmm.
And the Brits taking seeds of rubber into Malaysia and Southeast Asia and building up a rubber industry in that part of the world, and an economy that was developed in the Amazon ceased to develop because that industry shifted away to Southeast Asia, making the Amazon poorer, if you will. But I'll first answer your question, and then I think we can explore the other important dimensions that you raised about indigenous and traditional communities, which are extremely important in this play. Back to the invention side. There is a myth. There is a myth which is very embedded in our day-to-day conversation, which is that by bioprospecting, i.e. by visiting one of these high biological rich hotspots, someone will find a species of a plant or a snake or a bacteria or whatever species, and that species will produce a biochemical or pharmaceutical of very significant value. And the truth of the matter is that the probability of such event occurring is probably less than 1 part per billion. And so what we are focused on is not the individual molecule in the pharmaceutical space, for example, just to simplify it a bit, but rather we see the value of pools of data at the Amazon biome level. You can contrast it with...
Would you just say something about what you mean by the pool of data at the biome level?
Yes. So it's much less interesting to have the genome sequence of a particular species, X, as opposed to having the genome sequences and the related genomics data sets of all species in the Amazon basin as a whole.
Mm-hmm.
Because then you can search for protein X that is a target for disease Y.
Mm-hmm.
Or you can search for material X targeted at application Y. And so it is a data and a digital play in that regard. It is not a one-to-one. It is very much like, people think that privatizing our own private experiences is the largest industry by far today, and today probably is, unfortunately. But the largest by far opportunity that the world has over the next few years in this century has to do with biology. Mm-hmm. And has to do with making sense of the book of life in the way that I'm describing it, not on a one-to-one, but on mining a pool of data. And so it is a data play.
So it's not simply about finding the next salicylic acid off the inside bark of the willow tree. It is a much larger based play, looking at a stream of data across multiple species and their interactions.
For sure.
Okay,
sure.
so let's jump, because we have about 12, 13 minutes left. Let's jump to, I think, another issue, which was I talked about the kind of virtue-based rationale here.
Yes,
And we've had a couple of questions come in that both that touch on this. I'll read them both out and then sort of frame them together. So from Robbie, he asks a question: is there a non-technical part of your vision that seeks to know more about the indigenous episteme that is already there, sort of a wisdom that already exists? Number one. The second question that's related to that is, how do you make sure that local communities have a voice and can benefit from this project? And I think those two are both related to this sense that we might do this for reasons other than our own profit seeking or our own avoidance of loss.
Definitely. Extremely important. And this is the most important issue of them all. Because we have hard science and technology problems, but as you rightly said, they are solvable. Now, let me go back to what I said in the presentation very quickly, which is, we're not after a bioeconomy per se. We are after an inclusive bioeconomy. What does that mean? That means that whatever we do, we need to do it in full respect and in partnership with traditional and indigenous communities at the center of whatever we do, because the genomic data sets and the applications of these data sets thereof to generate multiple innovations have to be very respectful of the Nagoya Protocol and the principle of access of these genomic data sets with fair and equitable benefit sharing if commercial value is obtained by using these genomic data sets. Now, the search function for these genomic data sets and for these innovations, of course, can be constrained. The search itself will be constrained, importantly, by traditional knowledge and indigenous knowledge that over centuries have understood what are the right constraints in how species behave together, and in particular in different regions, in different ecosystems. And so we believe that traditional knowledge and this cultural heritage is an extremely valuable asset and should be remunerated and should be funded and should be respected, which is why the implementation of the Nagoya Protocol for using this data for whatever purpose, whether it is scientific, whether it's commercial, has to be fully part of the play. Otherwise, what we will see is a bioeconomy that is not inclusive, that is actually developed in the Silicon Valleys of the world, in the Bostons of the world, in Europe, in China, in Japan, and will not happen in the tropics.
I mean, just for the audience, I mean, the Nagoya Protocol is this 2014 protocol that talks about the fair and equitable sharing of the benefits of genetic discovery. I mean, it's in stark contrast, I think, to what Celera did when they first sequenced the human genome. I think, am I not correct in thinking they tried to actually patent the genome initially, and that was rebuffed. So you're going to generate a lot of this very, very useful data about the genomic richness that exists, and probably kind of proteomics and other systems level flows. How are you going to make sure that those things are going to be served equitably? I mean, is there a model of a commons that will be managed by some kind of trustee, or is there's some other structure you've come up with?
Yes, and so we for the last 2 years we've been designing and prototyping what we call the Earth Bank of Codes, which effectively is a regulatory technology. It's a digital regulatory technology that, in simple terms, will be able to understand the provenance and will have full value chain traceability, so that we can square the circle. What do I mean by squaring the circle? On the one hand, we want to make all genomic codes open and available for scientists and innovators around the world, because the world needs these solutions that will solve for all our, or most of our problems, on the one hand. But on the other hand, we need to ensure that fair and equitable benefit sharing actually occurs, which is what you mentioned there about the Nagoya Protocol. And so squaring that circle has to be embedded in a regulatory technology that we call the Earth Bank of Codes, which is being incubated inside the Center for Global Public Goods of the World Economic Forum.
Ah, okay, fair enough. Right. So let me come in to this point. We've got a few minutes left, so we'll just try to get through as many questions as we can in the remaining 6 or 7. One of the things that struck me about this particular aspect of the governance, and in contrast to the very early internet, so I'm talking about the internet to about 1993, 1994. With that internet, the governance was actually inside out. So the governance existed from the people who built the network of networks, for themselves. They were the participants, and they ended up with this sort of bottom-up system that worked, quite well for them and quite well from the aspects of the closed, endogenous closed view of the internet itself. I mean, people living outside the internet in the late 90s may not have been happy with some of the decisions they made, but that group did it fairly themselves, and you can see how they were almost coming from the original position, coming up with a social contract around those particular mechanisms for governance. When I look at in particular the vulnerability of the indigenous populations within the Amazon, and actually the sort of the non-indigenous but local Brazilians who are living in that area, and you look at the sophistication and the complexity of these technologies. I mean, they are much more complex than internet technologies. You're just in the last 5 years hearing venture capitalists talk about computational biology being the next platform. So how can you authentically say that this is going to work for the benefit of these indigenous people, given that the sort of structural reality of the sophistication of these technologies and the fact that you're approaching this from the outside in?
Yes, but that's a fantastically important question. So it is outside in and it isn't. It isn't because everything will be hosted by Amazonian institutions, and it will be it will be done by Amazonians and for Amazonians. And so an instance of what you've commented there is twofold. One is that we currently do not have the science, technology, and innovation capability in the Amazon basin. We have very little capability and capacity. And if we don't have that capacity, of course, the insertion points of these advanced technologies is difficult, as you rightly mentioned. On the other hand, the access and benefit sharing dimension it's crucial to get right, particularly at a pan-Amazonic level. And for that, this will not be implemented from the outside in or even top down. This will be implemented bottom up through regulatory sandboxes on per country level, of there are 8 countries in the Amazon. And the regulatory norms vary across the 8 Amazonian countries. And these regulatory sandboxes will not only include the usual characters from the public and private sector, but importantly, must include the owners and the carriers of traditional knowledge, which of course are the traditional communities and the indigenous communities that you mentioned, and therefore, whatever is done will have their design and their shaping from the inside out and from the bottom up, and not from the top, because an approach that is outside the Amazon and implemented in the Amazon would never work, I believe.
We've got 2 minutes left for the last question. So I want to ask about the political realities of all of this, because, Brazil's politics is in a particular place right now. And I'm curious about how you think the current politics would allow for this. I mean, Bolsonaro sees the Amazon in a sense as a cash cow, but very naively, right? Chop it down, turn it into sort of cattle land. What do you think are the paths to get the realities of being able to get Brazil as a nation on side, given the realities of the politics there? And please be optimistic in your last minute and a half.
Yeah, I think governments come and go, and that in reflecting about all the governments, perhaps, of the Amazon region, unfortunately, they over time have only focused on the natural resources, the land, the timber, the mineral resources, the oil and gas, etc. If you add up these resources, there's probably about $250 billion in GDP in the Amazon. And we're talking about a bioeconomy of trillions of US dollars. And so the economy that I was referring to is the extractive economy. And I think governments in the region of the 8 Amazonian countries have come to the conclusion that a commodity-based economy has its limits, and the limits have been reached. And we see the impacts in terms of inequality and different issues in Latin America. And therefore, I am optimistic that governments in the region, as they reflect about their last 30 years of relative successes, but also significant failures, that this new model could be an optimistic way out.
JC, well, thank you. That's all we have time for. It's wonderful to hear your plans for MAGA, Make the Amazon Great Again. It's a wonderful vision that you have, and I'm really grateful for you for taking the time today.
It's a pleasure.
And that brings this stage for CogX 2020 to a close. I will be saying goodbye now as well. I'm going to switch over to the main stage where Tabitha and Charlie are going to reflect on the last 3 days. Thank you for being with us.
Want access to more CogX videos? Subscribe now for free at cogx.co.